Hi, this is Dr. M. Gangappa, Faculty of CSC, AML, IoT and RAI. Today I am going to discuss one topic in the subject Automata and Compiler Design. Topic name is LEX Programs for Finite Automata. So today's agenda is the following: LEX programs and its format, and regular expressions and basics, implementation of finite automata for some examples. So let us start the LEX. So already we know that what is LEX. LEX is a language recognition tool that can be used to implement the lexical analyzer. Lexical analyzer is the first phase of the compiler, so that generates the tokens for the source program. Now let us see the LEX program format. So LEX program structure can be seen like this. It consists of the following sections. First one is declaration section, transition rules section, and auxiliary procedures or functions section. So these are the three important sections we need to remember while writing the LEX program. Declaration section, already you know that declaration section is quite similar to the declaration section in the C programming language or some other programming language, and the transition rule section is quite different from the other programming language. Here transition rule section consists of the following rules. First one is pattern followed by corresponding action when that pattern is recognized. So pattern 2 and corresponding action that is to be taken on that pattern. So this is the structure of the transition rule section. So one of the example for the transition rule section is seen like this. Suppose you want to recognize a word. In order to recognize a word, first we need to write the pattern. Pattern is a regular expression. So regular expression for recognizing a word can be written using the character class as A to Z, capital A to Z, whole star. So this can recognize the characters one by one until that word is recognized. So whenever this is this rule is recognized, immediately it will print the word. Some of the basics we need to understand before going to write the LEX program. First rule is dot. So whenever we need to recognize a single character in the LEX program, in that case we use dot. And suppose you want to recognize 0 or more number of characters, in that case you can go with the star is the symbol. Next symbol is plus. Plus symbol can be used to recognize one instance or more than one instances, or one character or more than one characters in the regular expression. Question mark is one of the important one. So using that question mark, we can recognize either 0 characters or 1 character. Means it can recognize at most only 1 character or 0 characters. And pipe symbol, that is a vertical bar. Vertical bar can be used to recognize the matched patterns, either one. And the character class, this is one of the important one. With the help of this we can group the stream of characters. And suppose you want to group the words, in that case you can go with parenthesis. And suppose you want to make the string a constant, in that case you can go with double quotes. So these are some of the basics of the regular expressions. So with the help of these regular expressions, we can write the regular expression or pattern. So with the help of that pattern, lexical analyzer generator tool, LEX, can recognize the words in the source program. Some of the examples for the regular expression. Suppose you want to recognize the integer. Integer can be 1, 2, 3, 4, 5. Here 1 is a digit, 2 is a digit, 3 is a digit, 4 is a digit, 5 is also a digit. So these are the total 5 digits. Suppose first digit can be written from 1 to 9. In that case you can go with the character class of 1 to 9. And remaining digits can be written by using 0 to 9 digits. Therefore 2, 3, 4, in place of 2, 3, 4 we can use the character class 0 to 9 whole star. Similarly word is a sequence of characters, already we know that. So in order to recognize the sequence of characters, here we can use one character class, that is A to Z, capital A to Z, plus. Already you know that plus is the symbol. With the help of that we can recognize one character or more than one characters. And similarly, signed integer format can be either positive integer or negative integer. So for that, here positive integer or negative integer means symbol can appear or cannot appear. So in that case, what should we do here is we should use the symbol question mark. We should use the symbol question mark. Question mark can be used to recognize either plus or minus symbol or nothing. And 1 to 9 and 0 to 1, 9 is already explained by taking an integer 1, 2, 3, 4, 5. And similarly, floating point number can be recognized by using the regular expression 0 to 9 star double quotation dot 0 to 9 plus. Right? These are the some of the examples for the regular expressions. Now let us see one program for recognizing odd number of A's. So let us see how to write a LEX program for recognizing odd number of A's. So first what should we do here is, first we should take the language. First we should take the language L. L is the language. In that language we should recognize either single A or AB, A or ABA, B, ABB or and so on. Means in this language we should recognize only the odd number of A's. Here there is no restriction for the B's. So here you can take any number of B's. So in order to construct the regular expression for this, first we need to draw the diagram, that is called DFA diagram. DFA diagram can be seen like this. This is the DFA diagram. So with the help of the DFA diagram we can recognize the language L. So when we solve this, when we convert this DFA into regular expression, then regular expression can be seen like this. This is B or AB star A whole star AB star. This is the final regular expression for recognizing odd number of A's. Odd number of A's. So in order to write a LEX program for this, let us see how to write it. So LEX program for recognizing the odd number of A's. So first step is a declaration section. In the declaration section, here we can declare the header files hash include stdio.h, and after that we should declare the variable reg. Reg is a variable. With the help of that reg variable we can recognize odd number of A's. This is the regular expression already we have seen in the last slide. So now we should call this reg variable in the curly bracket to make it as a pattern. Now it becomes a pattern. Whenever a pattern appears, then we should take the corresponding action. What is the corresponding action? So whenever the odd number of A's are recognized, this recognizes the odd number of A's. Whenever odd number of A's are recognized, then we should take the action. What is the action? Action is accepted. Suppose odd number of A's are not recognized. In that case, it goes to the dot star. Dot star can recognize not odd number of A's. So in that case, the corresponding action is, this is the corresponding action, right? And the main function can be written like this. Enter the string YYLEX. Already you know what is YYLEX. YYLEX is a function. With the help of that function, it can scan the input string that is supplied to the program. So all the strings that are supplied to the program are passed to the rule section, transition rule section. This is the transition rule section, right? So this transition rule section will verify the input strings one by one by using the rules, rule 1 and rule 2. Here we have written rule 1, this is rule 2. Suppose rule 1 is for recognizing the odd number of A's, rule 2 is for not recognizing the odd number of A's. This is the simple program. I hope you could understand this. Now let us see how to implement this program in the Linux environment. So let us go with the program. So this is the Linux environment. I hope we could understand how to open this. So at the prompt we should use the command vi. Vi command is for vi editor. Already I have written the program. Program name is 1 minute. Let us see what is the program name. Oh, cd LEX programs. LEX underscore programs. VI space DFA1. So this is the first program, DFA program, for recognizing the odd number of A's. So this is the program. Already I have explained this program. So this is the declaration section. In the declaration section, I have declared the header files that is required to perform the input and output operations. And this is the regular expression, and this is the variable name. The regular reg underscore dfa is the variable name, and the corresponding regular expression is this. This regular expression is required to recognize the odd number of A's. So after that we have called this variable reg underscore dfa when this is a pattern. So whenever this pattern is happened, in that case the corresponding action will be taken. So otherwise it will go to the next regular expression, that is the string not accepted, right? The main program, this is the main program. In that main program, printf, enter the strings to verify in the language. After that YYLX, already you know that YYLX, already I have explained. This is quite similar to the scanf function in the C programming. So after that YYWrap, this is required to indicate end of the input, right? Now let us run this. Let us save this. Escape, shift colon WQ. So this is how we can save and exit from the VI editor. After that we should compile this program by using the command lex space dfa1.l. So this is how we can compile this. After compiling this we can get one C file. The corresponding C file should be compiled by using the C compiler cc space lex dot yy.c. That's it. Enter. So after that we should run the program /a.out. So after that we should enter one input string to verify whether that string is in the language or not. Here I am entering A, B, A. So number of A's are 3 and number of B's is 1. So therefore this is the acceptable string. Let us see what we get. So string is accepted. AB, AA is accepted. Let us go with one more. Control Z. So already I have one file. Let us see that. VI space input file input.c. This is my file name. So in this file I have taken some set of strings to verify whether these strings are in the language L or not. So to supply this input file to the program, we should use one more command. I will /a.out, supply the input string, input file input.c. So observe here, first one is A is accepted because single A's, and ABA is not accepted because number of A's are 2, and ABBAA, here 3 number of A's, here 3 number of A's. These are accepted and these are not accepted. So like this we can write the LEX program for DFA implementation. So let us come back one more. So one more program. This is for sake of understanding. The one more program is implementation of Finite Automata using LEX language for recognizing the even number of A's and even number of B's. So first what should we do here is, first we should draw the DFA diagram for even number of A's and even number of B's. This is the DFA diagram for even number of A's and even number of B's. This is the acceptance test. This is right. So from this diagram, what should we do here is, first we should convert this diagram into regular expressions. So when we solve this diagram by using some rules, then we can get one equation that is the regular expression. This is the corresponding regular expression we can get for this diagram. right? So what this will tell us is the above regular expression will accept the words having all even number of A's and all even number of B's. Not only that, and the word that contains even length of A's and also B's. So right, so now we are going to implement this. Here I am going to show you how to write the program for that. So this is quite similar program to the previous program. So here is the declaration section, and this is the regular expression for recognizing the even number of A's and even number of B's, right? So after that, whenever even number of A's are supplied, then string goes to here, because that string is acceptable string. And suppose even number of A's are not supplied, even number of A's and even number of B's are not supplied, in that case that string will go to this part, means that is string is not accepted. So like this we can write the code for implementing the DFA by using the LEX. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.